Welcome everyone to another presentation offered by Thought Technology. This time we're coming to you with the aid of our partners, Evoke Neuroscience, and specifically their CEO, Dr. David Hagedorn. For those of you who might be familiar with my voice, perhaps because you attended one of our live presentations or listened to one of our recordings before, my name is John Bale and I'm one of Thought Technology's product managers. Today's presentation is going to focus on taking QEEG results and using them for neurofeedback, but more specifically, how you too can bridge that gap with a QEEG evaluation, specifically Evoke system, and how you can turn that into an effective neuromodulation plan using thought technology systems for low-cost neurofeedback and other biofeedback-based interventions. Now, we have quite a mixed group in attendance today. Some of you are more familiar with thought technology in our systems, and others of you are more familiar with Evoke's QEEG system. And so I'd like to provide each of you with an introduction to the other, just so that we have some familiar beginning to this presentation and the content we're going to be covering. So for those of you who are not familiar with thought technology, we are a medical manufacturer. We make both hardware and software that's approved in quite a variety of countries and according to their different medical health bodies. We've been in this field for about 45 years. And so ever since the field of applied psychophysiology and biofeedback began back in the late 60s, early 70s, we've been around. For that reason, we're quite well known as well in the field in terms of what modalities we measure and what services we provide in terms of neurofeedback and biofeedback-based therapies. In particular, one of the big things we're known for is how we mix and match these different modalities. So some people want to measure brain waves or EEG, and we allow for that. And some people also want to measure heart variability or muscle tension or breathing or sweat or temperature, to name a few of these modalities. But what particular people like our systems for is how we can do all of that and actually put it together in terms of different EEG or psychophysiological-based evaluations and results. We've worked with quite a few different groups in our time, and so here's some names of a few of them: NASA, Ferrari. We are in universities all across the world. We're embedded in a lot of different Olympic committees across different countries, and we are in a lot of different major sports leagues. This includes all the major sports leagues of the United States, and most of them in terms of Canada, Europe, as well as Asia. So we have been around for quite a while, and we have provided a lot of different groups with different successes and utilities. Now, I did mention a lot of sport here in performance. We are well known in the peak performance circles. However, a lot of our work does relate back to clinical problems with normal people or pathological situations, things related to stress, things related to rehab. It really depends on what the field is, but we are in quite a few different ones. For those of you who use our systems, this might look a little bit familiar, but we make different systems based on whether they're starter or more advanced. Right here in white is our little Procom 2 system that lets you record from 2 different sensors or 2 different channels. So if you're using this for neurofeedback, you'd be able to do neurofeedback training at 1 or 2 EEG sites. For our more advanced systems, we can record with up to 8 sensors, or actually even more. And this lets us mix quite a few different modalities together. So you could look at EEG, but you could also be looking at heart rate variability and other physiological metrics. For those of you who use our system already and use the starter system at the top, you most likely have 1 or 2 EEG sensors. In this example, this is 1 channel of EEG placed on an individual. And this is a great way of getting a simple EEG assessment, as well as doing some really good neurofeedback training protocols. For those of you who have one of our more advanced systems, chances are you use quite a few different modalities. And so the subject might have a few sensors on their hands, other parts on the body, as well as electrodes on their head, depending on what you want to look at and what type of psychophysiological evaluation. In terms of the software and the data, those who use our systems for EEG typically do one of these 3 types of evaluations. So either on the left, you do amplitude evaluation of EEG at 1 or 2 sites, and this will give you a full breakdown of all the brainwave patterns that are going on. Alternatively, if we look at the center, you might be doing some type of normative database evaluation where you're comparing the person's EEG to a database and it returns back a result in terms of standard deviations away from the norm. Otherwise, you might call this a Z-score evaluation. And as a third type, there's actually quite a few different third types, but it would be more of a clinical evaluation where you're following someone's clinical method. In this particular example is Dr. Swingle's clinical Q. But there are a lot of other types of clinical evaluations. An arousal model might be another one. Following the Thompson's method is another choice. There's quite a few different things one could be doing with our system in terms of software. Now, that being said, The one thing that we, Thought Technology, do not currently provide is a QEEG evaluation, so a full brain map, as one might call it. This is where Evoke Neuroscience comes in, because in the field of EEG, the QEEG is the gold standard in terms of evaluation and data and reporting that it can provide. Our partnership with Evoke Neuroscience has really allowed our user base to access a group who can perform those full, large, excellent QEEGs. Similarly, Evoke Neuroscience has found our partnership to be useful because we give access to low-cost but effective neurofeedback, as well as heart rate variability and other physiological training tools that their system will not easily be able to provide otherwise. So although I am not a worker for Evoke Neuroscience, I'm happy to give a brief introduction to them, although I'm sure Dr. Hagedorn will have more to say on this a little bit later. So Evoke Neuroscience also is a medical manufacturer. Their QEEG system is FDA approved. They've been in this field for about 12 years in terms of identifying cognitive impairment with QEEGs. They've really focused on the medical health side of things, although they're entering more and more into the performance side of things, whether it relates to sports or performance in terms of military groups. Although I tend to talk about eVox system as a QEEG, that's really selling it short because it does quite a few different things as part of their brain health system. So it does look at EEG, but also looks at ECG, aka heart rate variability. It also does event-related potentials, and so this looks at how the brain reacts to certain stimuli and event. Within this entire 1 hour evaluation they provide, they also do a neuropsychological testing, which is really this no-go testing where a person clicks a push button when they're supposed to see an image and they're supposed to not click it for other things. They also look at biomarkers of the brain to compare for cognitive decline, and they also integrate a client questionnaire into the evaluation in terms of the results. So although I talk about them as a QEEG system, their health system looks at all these things simultaneously in a 1 hour evaluation and outputs a report based on all of that. So it's definitely cool. Now, for those of you who already have an Evoke system, this will look familiar to you. But for those of you who do not know them, there's just some images to help you get acquainted. So if you're running one of their evaluations, you'd have a full cap on the individual's head. There's also be some electrodes for the ECG. And they would be looking at a dedicated computer that runs Evoke's software. The software will walk you through every stage of the eyes open and eyes closed QEEG evaluation, along with the no-go, go protocols, as well as the questionnaires. You can see here on the image on the right, there's even a little push button included that the person has to click when they're supposed to do that part of the evaluation. All of the data then gets sent back to Evoke HQ for analysis, and they send you a report that you can look at in terms of the different subsections of the evaluation they provide. In this particular image, it's just the brain map, that's familiar kind of colored brain map we're used to seeing, as well as some other indicators related to performance and client health. So at this point, I'd like to give the presentation over to Dr. Hagedorn, and we're going to get started with the report that gets produced by the Evoke QEEG system. All right, Dr. Hagedorn, let's make you the presenter.
Thank you all for joining. Let me just start by saying, let's back up a little bit. A lot of times we get into neurofeedback and we just start thinking about protocols that we've seen or certain applications, and everybody might be familiar with 12 to 15 hertz normalization or increase over the sensory motor region of the brain, generally centrally from left to right. C3, CZ, C4, also a little bit more parietal to those sites. And that's not that uncommon of an approach to start from that end. But I'd like us to think about starting from the opposite end, which is the EEG in general. We know EEG is generated primarily from the pyramidal neurons processing information, firing in mass, vertically oriented toward the cortex, and we record EEG from the scalp using an amplifier. And I want to talk about just EEG for a moment because it's that core data from the brain that we generate quantitative EEG and that we also manipulate and modulate with neurofeedback or EEG biofeedback. So the approach that Evoke took, and back when I was working for the Navy with a lot of brain injury, was I needed really good quality EEG first, in order to determine and quantify what's wrong with the brain, and then from that data come up with a targeted, individualized treatment plan. And that could take the form of surface amplitude training, inhibiting or rewarding certain frequencies at certain locations on the scalp. It could include surface single channel or multiple channel Z-score training. It could include Brodmann targeting using Loretta technology, allows us to then target certain XYZ regions within the brain. But it all starts with good EEG. So I want to talk about that briefly. In Evoke, we started, some 12 years ago now. I really kind of got it rolling around 2008. And the objective was to find a faster, more automated way to collect good data easily so that the learning curve would be shortened for the pretty typical novice user where I was with technicians and Navy corpsmen. And that just kind of grew into the civilian population with physicians around the country that use the Evoke system now too. But when you have the EEG recording, and Evoke's amplifier is 24 channels, it's an FDA approved for EEG and ERPs, event-related potentials, and we'd like to start with what are we dealing with from an EEG standpoint. So we'd like to use another service whenever possible to actually have a skilled person look at the EEG. Here's an example of one case that I've got on the screen here. And this was of a girl that started Wellbutrin and started having insomnia and noticed there's some tics and movements that she didn't have before. And the quantitative EEG really didn't give me a strong indication of what there might be. So there was a suspicion because of the drug class that we might be looking at possible seizure activity in a child that didn't have it before. So having this analyzed by someone who's skilled at looking at EEG, it was important. And Evoke Neuroscience makes this seamless. The data just gets sent to the doctor for a manual review, looks at the EEG, looks at different montages. They start with link to your reference and do weighted average, etc., flash and montage, and they allow them to just take a good, clean look at the EEG. And that's a starting point. And we always start there because that's what, whenever we do anything in the neurofeedback space, it's manipulating that EEG itself. Right? The other thing that we do at Evoke is we also work with this company, on education. Because neurofeedback is often considered an adjunct or complementary service, so is the field of integrative medicine, functional integrative medicine. And most people don't have a strong understanding of that and how well EEG and EEG analysis works within the field of functional medicine. So this is an educational report, very different, clearly different from one where the doctor's actually looking at the signal, analyzing the signal, making comments about it on the prior report I showed you. And then this one is an automated educational report, and it has things like self-report data in table form, commentary if there's an abnormality, what it might mean. If there are some symptom questionnaires like the PHQ-9, GAD-7, PTSD checklist, to get an idea of what might be going on with the person from a symptom standpoint. So it's a very quick, and this one's free. Evoke just includes this in there as an educational service. That this particular one, the heart rate data wasn't available. Peak alpha, in this case, wasn't generated. Motor speed, theta beta ratio, different other ratios, and then Evoke potential measures with some narrative. And this is really educational in nature because no one's actually looked at this. And then this is a very abbreviated quantitative EEG where you're looking at Z-score differences by different frequency bands by region of the brain, frontal, central, parietal, and temporal. So it's a kind of a 30,000 foot view and a different display menu than what we might be used to seeing from the typical QEEG reports. So I just wanted to make that as a starting point to you all that we are looking at EEG when we're doing neurofeedback, and we should, have that looked at carefully and meticulously, and because just like in research, you always look at your raw data, and we should not miss that step when we're doing neurofeedback work to always have an idea of looking at your raw data from the start. So here's a typical report that's generated from the Evoke system. And it's basically kicks back. This is the research grade report, what has more data than a standard one. There's about 5 different report template options that are all, some people like one over another, but it gives you information like motor speed, reaction time, variability of reaction time, which is quite a sensitive measure in head injury. It seems to jump up very quickly when you have even mildest concussion. Errors of omission or commission. This is generated by a continuous performance task when you see a stimulus on the screen to be able to discriminate and press a button. Those who have hyperactive will press the button prematurely or impulsively, for example. Others will just not be aware or alert enough to what's going on around them and not press the button when they're supposed to. So we get that kind of data in the typical neuropsychological CPT task here, and that generates these kind of statistics for you. Heart rate data is very important. We always like to look at the autonomic system in conjunction with the central nervous system, and the heart rate variability is a great way to do that. So we'll get things like an SDNN score, which is a time domain measure. We'll get a total power value. We'll get frequency measures, and I'll show you those graphically here in a second. I'm showing you this page because it comes along with some values in correlated function. So for P300A and B, these are evoked potentials here. If they're elevated, it'll signal what kind of symptom or function might be involved. And it shows references here to an educational manual, which shows you the research reference that supports that. And it'll give you some Brodmann areas that are featured as being outside normal limits, if they are. And I'm just kind of scrolling a little fast because I want to show you the graphics. So the first couple pages of this is really designed to give you a table rapid review format. And then after that, it opens it up. The same data is shown more graphically. Here's the heart rate variability information. You see here, we've got, you can see the R wave quite clearly. It's good to visualize that. The one below that is another common display of HRV. You'll see this in the thought technology software, which makes it a very nice comparison when you have a baseline measure. You can use this to talk to your client, your patient, or athlete about what you're going to do in training to try to create a nice sine wave looking pattern here, which shows good variability. And we use this screen when we're talking to patients about the report or athletes and showing them that where there's room to improve and how using the different thought technology platforms for heart rate variability can be most useful. They have portable home use versions as well as office space equipment. There's the frequency, FFT, you can see here on the right, and it shows where the dominant frequency is, and it's just a little bit more of a very low frequency power shift than we typically would like. So we probably would do some training with this person as well, and dial in on the right respiratory pace to produce an optimal peak, and we'll try to get the maximum amplitude. And the thought technology HRV suite is really well designed for this type of work. So you see a little bit on the time domain and the frequency domain measures that you get from the Evoke assessment. You can see how they perform under task. So the task condition is a little more stressful. It's we're recording the ECG data. It's a 3-lead ECG, not a BVP, blood volume pulse. We use ECG leads. And we get this information, and it's nice to see how they are at rest and how under a small demand condition they may respond differently. And this person's pretty close to the same, which is good. Here's what Evoke potentials will look like. So there's a visual processing task, getting a sensory measure, and it's a little delayed for this person, 276 milliseconds of a delay in visual processing. I'd like to see that a little bit faster. The P3A is quite notably delayed, and it says indiscernible, but it's definitely right around just beyond 800 milliseconds, and that's a very significant frontal orienting response that's delayed, and that will be definitely would be a target for intervention. So we can see the slowed processing speed in the anterior portion of the brain. The working memory was okay. I mean, typically this is about 50 milliseconds slower than a P3A. The power's okay, but the main focus would be attention here in this patient. And we want to see that same kind of pattern of information show up in the quantitative EEG. So I'm going to jump ahead to, there's the raw EEG images, all right? And again, the whole series of EEG is nice to review it, and the EDF files are included, of course, so you could process your data in other software. I processed the EDF files, and whether it's in EEG Lab, in the HBI database with WinEEG or Neuro Guide. It's really nice to be able to look at it and remontage it yourself, or send it to a service like NeuroRead that will do the same thing. And then here's what you're maybe more accustomed to seeing when you think of QEEG. So we have a peak alpha in this person, 9.9 hertz, that's normal. And we typically record the eyes closed for good reason. I won't go into all the reasons now, but we generally like to get that occipital measure of dominant alpha or peak frequency, occipital frequency of the person. Generally, it's thalamically driven. We know the alpha is generated from different locations, but we're mostly looking at the thalamic clocking speed. So the QEEG here shows, if you're not real familiar with it, in this case, the scaling green is within normal limits. And the general report shows the scaling, plus or minus 2 standard deviations. You start to see this is starting to approach 2 standard deviations of 13 to 14 hertz excess centrally and frontally. While for the most part, everything is fairly within normal limits. There's some low power occipitally here. A little bit of low power in alpha, in theta as well at 5 hertz. So from a quantitative visualization of these colored heads that people are used to seeing, you can get quite a bit of information already just from that page when you're thinking about a neurofeedback program. So I may jump right over and start at CZ on this person with a single channel amplifier from Thought Technology, whether I've got 8-channel, 5-channel, or any of their EEG suites. You'll be able to train the EEG frequency in this person closer to normal limits. And what's nice about Thought Tech equipment as well is you don't have to do another 19-channel EEG every time you want to see changes. You'll be able to do a recording and look at the 1 hertz spins that John mentioned at the start, and just look at the FFT of each frequency at that channel and see how it's improving. And that is, again, that saves a lot of money as well as time. Also in this report are these tables. Now these tables, in this particular one, here's an eyes open table of just the frontal of all the 19-channel 1020 locations at the top, and then you have 1 frequency bins in the other axes, and showing where are you outside 1.5 standard deviations. It lights those areas up. So we're looking at CZ is a good target, F8, F7, probably would start at CZ if I'm doing one-channel training and eyes open. Here's eyes closed right here, and we see that parietal low power stick out suddenly as an issue with this person, and when the person closes their eyes. That might be another area of clinical focus. Okay. We have show the EEG under task conditions, so we can see what happens when a person is put into a more stressful mode of performance. We get quite a different, more deviant activity frontally here, and you notice the theta excess frontally as well. So it's starting to show us that we do have some issues in the anterior cingulate region. The Evoke task is the demand condition, so you can see how a person under a stressor condition during a 15-minute task can 10 to 15. We do as little as 10 minutes to collect the ERPs, but sometimes we'll increase that number to 15 minutes if we want more data. And just to see what happens under a task condition. If it's outside 2 standard deviations, the Loretta will be targeted. This person was just short of 2 standard deviations from difference from normal, so it doesn't pop up and the eyes open, but the eyes closed, it did. And it says, okay, we have problem in Brodmann area 40, which is the post-central gyrus. We can see how far from normal limits it is. And we also can see a table which shows you more than just 3 Brodmann areas. So here you see a table. Here's eyes open. Here's all the left. This is left hemisphere frequencies at the top, 1 Hertz spins, and then here are the Brodmann areas on the left. So this person, Brodmann area 4, excuse me, Brodmann area 27, frequency 4 is 2 standard deviations from normal limits, and that's the most telling area in the left hemisphere for that person. A right hemisphere had problems in Brodmann area 47, also at frequency 4 Hertz. And then in the eyes closed condition, there were nothing on the left hemisphere and nothing deviant in the right hemisphere. So that's a quick look at the different ways that we look at the data from the equipment and make decisions about what to do with it. So it gives you it's like big data, and then allows you to look at it and strategize what you want to do when you flip over to the thought technology suites, both the thought technology HRV suite, which we use quite a bit, and the EEG suite. And John's going to show you some of that. One of the things that we also like from Thought Tech is the Z-score suite. So that makes it a little bit easier to not have maybe as much understanding of which frequency bands you want to train. The Z-score option can help simplify that for you a little bit. So John, I don't know if you wanted me to answer any questions at this point or allow you to move into illustrating on the thought technology screens what the training might look like, and I make some comments about how I pull data from a report of a 19-channel EEG with 3-lead ECG and Evoke potentials and make that transition.
We don't have some specific questions about that, but someone is asking about sample reports so they can better understand what they can get out of the Evoke system. And so I'm sure from your website you might have a sample report. People can have a look at that as an example.
Yeah, you could simply. That's a good question. And because I threw this one up there. There's many different report samples. So I just picked a research grade report. I picked the neurologist EEG review. And I picked the educational no charge neuro read report, which people get. But there are others. There are even 1-page simplified reports that you might hand a patient, which is just not 30 pages of information. That would just a seizure by looking at it. But yeah, if you contact Evoke at info@evokeneuroscience.com and you ask about different samples, one person in the office would be happy to share that with you. It's a It's a system, if you're not familiar with it, it was just, again, designed, it's not new science. It's just taking a good quality chip, an amplifier, making it wireless and small, and having an automated software, because the equipment ships with caps, laptop, preloaded software. You never load software. You'll never see a CD for loading software. Any updates are done remotely, automatically. And it was just designed for that purpose. Now, the downside of this system is you don't have all the research grade tools for manipulating stimulus type or changing your ERP timing or things like that. It's locked down. It just does one thing over and over again. And Evoke's got about 90,000 cases now of recordings of people around the country, and it was just designed to simplify the process. But then you move into the thought tech equipment for doing the neurofeedback and biofeedback, and you have a pretty seamless, simple to apply approach where you get big data, then you jump over and you start training with that equipment.
Okay, so let's follow on your original thought of let's show you how this might work out using the thought tech system for the training, and then we'll get back to some more questions about the Evoke. So let me make myself presenter, and hopefully you're able to see a screen right now, and it might look like there's a house with a tree. Does that sound right?
Mm-hmm.
All right. So in what Dr. Hagedorn was showing, there is a massive report that gives a lot of amazing and dense information. However, from that information, we can create a training protocol or training program for our individual client within the ThoughtTech software. Right here, I've loaded up one of the standard neurofeedback screens from the 360 suite. It's the standard neurofeedback training that we provide. And here in this typical screen, you can train 2 different frequencies based on what that goal could be from the Evoke report. So if I recall, you said that on this particular example of a client we're looking at, they had, I think, an excess of theta activity essentially. Was that right?
That's right.
All right, so excess of theta activity is what, somewhere in the 48 range?
Yeah, we saw that there was anomalies at 4 hertz, and that was one area to train. And we also saw there was an excess of beta 1 centrally under any task condition, which was probably contributing to some of the sleep problems the person was having, and probably a side effect of the overactivating norepinephrine binding drug that she was taking.
Okay.
So that's just a good point, John, to mention. Just because we see an anomaly in EEG doesn't mean neurofeedback's the only treatment. We may be looking at drug changes as well, or other things. So we have to not be myopic and just think that if you have a problem and you have a hammer called neurofeedback, everything must be a nail.
You are absolutely right, and that this is just one more tool in the toolbox of possibilities you can use to move forward with that client that's showing atypical brain patterns when they come in for that QEEG assessment. So if we were to choose that, if we were to consider neurofeedback as a proper option for that individual, we would have to first decide what frequency ranges do we want to train. And so if we were to focus on that initial, you said excess at 5 hertz, that theta range 5 hertz.
Yeah, just for example's sake, just say we have an excess of 3 to 7 hertz. Theta is dominant at CZ and FZ, and you want to suppress that with the equipment. It's very easy to set the parameters of frequency, which John's doing now on screen. You see this, or you quickly plug in the range of the frequency that you want to manage or modulate.
And then that becomes the focus for our training in terms of that particular bandwidth. So right now, red represents the 3 to 7 hertz. And in this particular example, automatic threshold, and we are trying to, make that below the threshold, aka we're trying to inhibit that excess of theta. Was there another range at this particular site, or do we only want to train one frequency?
What's interesting here is a lot of times people will try to increase 12 to 15 hertz. And not every patient needs that. in this particular example, I probably would not be rewarding 12 to 15 hertz. So I might be looking at a higher frequency band muscle activity to try to capture. So I'd probably set it first, and we are concerned about possible seizures in this person.
Okay.
So spindling starts at about 19 hertz. So I would suppress 19 to 30 hertz
Okay.
to try to capture that upper limit during the training, and kind of focus your training on beta 2 suppression and theta suppression.
All right. So now we have two graphs that are going to be doing suppression of the two frequencies we gave it. Red represents that theta, 37 hertz, and green represents that 19 to 30 beta spindling. And we can have the system automatically set thresholds for how difficult of a task this is, or how easy it is, or we can manually do it ourselves by dragging them up and down. And so here I've just taken a protocol from the QEEG as advised by Dr. Hagedorn, and then we've turned it into a neurofeedback training protocol such that we're going to get feedback in terms of this animation moves when both of the little bars are below the thresholds, and then the animation stops when one of them goes above a threshold. There's also music, which I can hear, you all can't hear because it's going through my headset, but the music also plays such that it's loud and easy to hear right now when the animation moves, and then when the animation stops, it goes soft and just is barely audible. So that's another way of letting the brain know, hey, this is the condition that I want to recreate, which is that lower theta and lower beta spindling. Let's say we wanted it to be, in fact, 3 bandwidths. This particular screen I chose happens to show 2 bandwidths, 2 training conditions, but we can move on up to show more conditions if that's what you want. In this example, there's 3. Similar, there could be 1, or you can have even more if that is what is of interest to you and what the QEEG protocol would suggest. Sorry, I believe I cut you off, Dr. Hagedorn.
No, it's good. I'm glad you showed that, because I like using 3 bandwidths, because if you want to inhibit 2 frequency bands, which is fairly common, and you want to reward a third, you'll need that extra band. So we would like to use that. We may want to reward alpha, for example, and a frequency, or even alpha 1 or alpha 2, a frequency band. So that's a beautiful feature here. You very quickly can inhibit and reward at the same time, and the person can see on the screen if they're meeting criteria. And on the criteria, we like to make the difficulty level about 85%. So what that means is about 85% of the time they're getting the reward. The animation and the sound is playing because they meet conditions set on screen by that threshold. If it's too easy, the brain doesn't learn quite as well, and if it's too hard, it doesn't learn quite as well. There's kind of a sweet spot there in how hard you make it to meet criteria and make the animation play.
That especially represents how quickly someone advances in a neurofeedback task. So initially, before we were mentioning this, the thresholds were stagnant at something that looked far too easy. But now the software kicked in because I left the automatic thresholds on. And so it's going to set itself to about 80% success for each individual condition. But in total, it's probably going to come out to a success about 70% if you think about these 3 conditions when they're simultaneously all correct to generate that visual or auditory feedback. So this is a simple example of how neurofeedback can be done in our software with an amplifier that's reasonable cost and it does not require you to use the full QEEG cap for this type of training.
Yeah, it's just a single sensor with an ear clip for a reference and a ground. That's one montage. You can use a different montage if you say you're at FZ, CZ, and then you have a ground, say on A1. That's another montage, and there's different reasons for one montage over the other. I think a little beyond the scope of this conversation today, but they're very quick to place on a person's scalp and easy to clean up, and they go on their day. So it's an elegant system with a lot of years of quality engineering behind it, and we rely on it, and it's not let us down.
I'm glad we've stayed reliable just as we've always been for the last 40 years. Moving on to a little bit of a different topic, you did mention ECG, or heart rate or heart rate variability. And so let's say there was a case where you in fact wanted to do some type of heart rate variability intervention. Our software also allows for that. Our equipment allows you to plug in a heart rate sensor, or alternatively, you can have some of our low-cost wireless sensors that just go on someone's finger, and you can teach them low and slow breathing to maximize heart rate variability and therefore aid in the rebalancing of the autonomic nervous system functioning. As a quick example on the screen I'm showing, I'm just going to unpause. There's going to be two lines. This is actually where we're looking at both the heart rate, which is the red line going up and down, kind of like a step pyramid, as well as actually breathing, which is this green line. And so we're teaching someone to do effective low and slow breathing somewhere in the range of 4.5 and 7 breaths per minute in order to maximize the overall heart rate variability and how that oscillates up and down. Let's get that statistics out of the way and just restart this replay. Feedback in this form of therapy, it's not like neurofeedback. One can be much more direct where the therapist is guiding the individual, letting them know if they're doing a good or bad job. It could also include looking at a breath pacer if that's necessary or what seems to be best. We can have silly little fun animations like shown here, but oftentimes this therapy can be learned in just a few sessions, how to get someone to do this low and slow breathing in order to maximize HRV. And then you can send them home to practice that once or twice per day. Alternatively, you can also just have them borrow one of these sensors, and with a smartphone or a tablet, they can download the free app and just practice their breathing following a breath pacer there. There's quite a few options. It really is a great way of getting them to learn how to maximize HRV to the benefit of themselves. Do you have anything to add on this, Dr. Hagedorn?
Just that there are a lot of pieces of equipment and apps out there, like using the light on the back of your phone. Really, when you're starting to teach this skill, you really need more equipment and you need more specialization with a respiratory sensor. You need the kind of data that you get here with the Thought Technology HRV suite. People can transition to those low-cost apps later, but I always start them out on learning a new skill with as much technology and accuracy as possible, getting them to understand that a certain breathing pace for one person is not necessarily the same for another, and dialing in on that RSA for them, it requires really medical grade equipment. So when I may give a person, and I won't mention the other companies' names, but there's a lot of good ones that sell portable, low cost, $100, $200 devices. Mm-hmm. And they may have those to practice, but I always start out with them acquiring the skill with all the details. And it just saves a lot of time in the long run, so they don't practice incorrect performance of HRV training on their own. They start out learning the skill correctly right from the start, and then they can go on with home use equipment.
Mm-hmm. That's an excellent way of looking at it, because you really want to make sure they understand completely and fully in front of you, and then they can kind of take what they've absorbed themselves at home and then follow that therapy under their own guidance as the time permits them. So these are two ways where the Thought Technology system works well with the evoked QEEG in terms of what data is outputted in its assessment, and then what can be followed up on in terms of training within ThoughtTech's BioGraph software. I'm just jumping over and looking at questions quite briefly. There's a bunch of people who do have questions about QEEGs because they're a little bit new to the evoked name. And so do we want to add anything else to this training aspect, Dr. Hagedorn, or do you have any other comments you want to make?
Well, I'll go jump into the question. So again, quantitative EEG is taking that EEG signal, you're starting out with good quality signal, and then quantifying it typically means you dissect it one frequency at a time. There's mathematical formulas to pulling out frequencies from, say, one channel of EEG. You can pull out the 1 hertz, the 2 hertz, and it calculates the amplitude or power of that wave form, and then it compares it to, say, a person, age, gender, normative example, which is a theoretical, healthy, normal person who's been through a lot of testing, evaluation to make sure that they're healthy, they don't have any symptoms. And that's quite a process to use a normative sample. There are quite a few normative samples out around the world now. handful of them, and they're all very good, and they all generate essentially the same results when you use a normative sample. So you're comparing that EEG to a normal example of a person by age and gender. There is a newer kind of approach on the block that I think is fraught with some problems. People are comparing a patient or an athlete to a clinical sample where we don't know exactly what drugs the person was taking, what conditions the person may have. So it's comparing it to a population of people, but it's not necessarily a healthy population. So you have to be a little careful with how you make inference from that quantification of EEG. I'm not saying it doesn't have a place and some value, but like I said, Evoke has 90,000 samples. So we could quite readily give you a report and show you how you compare to people in your age group, like 20,000 people in your age group, for example, but they're sick. They went to a doctor. I'm not sure I want to train to that standard. So but there's some application there, and there's a couple of those being done in the United States by some pretty big companies who may, and again, I think you always just have to know what your quantification really is, and then make a good, wise decision on how to use it. So that's what QEEG is, and there's different ways of analyzing the EEG with software. Like I said, you can look at different montages, as you should. They tell you different things about the EEG that's being generated in the brain. There's plenty of good courses on studying EEG, digital courses. The learning curve is not that steep. Interestingly, neurologists, for the most part, when they graduate from residency, they don't get that much training in EEG. A lot of them end up doing work after the fact, whether it's post-doc work or it's just learning on their own to become more specialized in EEG. So some people aren't aware of that reality. So all of us really have to learn and become experts and realize that there's a lot to learn in an area of the brain, and no one really has a full understanding of it yet.
I think you touched on exactly one of the questions people are wondering about. It's where they get more of that training on EEG and QEEG because they feel like they themselves are still a beginner, which, as you mentioned, if a MD comes out of their training and they still haven't had that much training, then there must be a lot of people who feel like children in front of a very large, steep hill to climb.
Yeah, and everyone is capable of learning this and then ethically using it with patients. So because you just have to, according to your licensing board, they will require that you only provide services that you're trained to do. It doesn't mean that you have to be a neurologist or psychiatrist necessarily. If you're a medical doctor, you're under the same obligation as a neurologist is to use information that they were trained and skilled ethically to use. So I know neurologists that have went back for training to learn how to do neurofeedback, learn more about EEG so that they can practice more ethically. And that applies to other disciplines as well. So there's a lot of sources. There's a couple different sources. The QEEGD organization, you can get a certification through them, and they teach quite a bit. There's bcia.org, which I think is a good place to start because it covers all of neurofeedback, biofeedback rather quickly. That's one of my favorite starting points. And then there's additional certifications that people can get, or just CME, signing up for learn about EEG through different CME courses online. Duke has and others.
Is there any particular clinical teacher that you tend to prefer in all these course providers?
I like to see a variety. I think everybody has a little bit information and different strengths and weaknesses, and getting trained from different people. Whenever people get trained by me in areas, I encourage them to also be trained by others who may have a slightly different viewpoint to give people as much information and try to avoid bias. And everybody has a little bit, even unknowingly. So I like to see people get a variety. But I think going through a BCIA course, if you haven't done one is really a good starting point. It'll not only acquaint you with EEG more, but also you'll know how and why to use different types of neurofeedback or biofeedback.
I have a slightly modified answer to what Dr. Hagedorn said, since I've had to attend a variety of BCI courses because the nature of my work. I find often certain instructors target the course to focus on the population they work with. For example, like Inet Rogel works with traumatized clients. And so if that is your background, if those are the people you want to work with, finding an instructor that focuses on that is a smart approach because it's already heading towards the population you know. There's other types that focus on performance enhancement. And so I would suggest just check into which instructor you're considering and see what type of people they train, because that's what they know well, and that's probably what they're going to base a lot of their training of you, the clinician, on. All right, we're coming towards the end of the presentation. I can see there's a variety of questions right here. And so some people are asking who they contact for thought technology equipment. I'm going to let you all know that I'll be reaching out to you if you leave a comment here, as well as you're going to be getting my email at the end. If you want to learn more about Evoke Neuroscience, I'm also happy to more discuss them and our partnership with them in acquiring that system. And looking at some more questions here, these seem very obvious in my mind, but when you're considering training criteria, when would you choose as training amplitudes, like I showed a moment, versus z-scores, which, just so you know, Thought Technology also has z-scores in their software. I just haven't shown you the particular screen for that. Go ahead, Dr. Hagedorn.
Right. So you are what the Z, depending on how the z-score is set up, you can if you pick one channel, say CZ, and you use a referential montage, for example, and then you have to use the montage that the z-score was set up to use, so it's comparing apples to apples. Okay. And what the software does is it moves all frequencies towards normal. So it looks at the amplitude of, say, 1 to 30 hertz at 1 hertz bins, and the feedback on the screen will basically tell you when all frequencies that you've selected are within normal limits. So if you are doing a z-score training of, say, just 4 to 7 hertz, it'll give you that aggregate or average amplitude of 4 to 7 hertz. And then if you set your z-score training to, say, 1, plus or minus 1, it means the variability of the amplitude of 4 to 7 hertz, when it falls within plus or minus 1 standard deviation from normal, you'll get the reward. So I like z-score training for that reason, because you can look at more frequencies at one time in some cases, but you get the same results in my experience. I would tell you that I've thought for years that z-score training was maybe faster. I don't believe that's necessarily the case. I think if you do a good quality selection, like what you see here on the screen, of certain frequencies based on your QEEG data, you'll get results as fast as I see when doing z-score training. So is there a need for it, have z-score training? I would say no. It's a nice to have, but you can still get really good quality results if you start with a good quality, quantitative, full head EEG, look at the data, make a decision on frequency bands and location of the brain that are outside normal limits that support your symptoms. It's important to try to tie what you're trying to do with the brain to modulate it with what you see on your data. Okay, they got to have a handshake and have an overlap in understanding. So if you're trying to help a person with focus and attention, you're most likely going to be dealing with the cingulate, broken area 10, 32, FZ, and that's the area you're going to want to see optimized if you're going to try to help the brain be alert but not hyper alert, and ability to focus and orient in a natural, relaxed way.
To follow up on that z-scores question that someone's asking, are there norms for children? Well, the whole idea of z-scores is that it's really comparing the subject's brain to an equivalent individual, same age, same sex, same condition, same eyes open, eyes closed. So yes, the z-scores does automatically compare. And so the normative database that Evoke uses in their QEEG compares that person to the correct type of individual of that age group as well. And then doing the training, same thing. You're always comparing apples to apples and not a 7-year-old girl to a 37-year-old man, because that's less useful.
That's right. And honestly, what we're learning now is you can have a normative reference group that is, say, a very homogeneous, peak performing, very high IQ group. The military may have their own sample that they want to compare people to, because they're comparing men between the ages of, say, 25 and 35. And their sample group had an average IQ of, say, 135. It's a different population than the quote-unquote average population. It's a very specialized group. And so if you were to train against that group, your Z-score may be 5 standard deviations from normal, not 2, on using another reference group. Okay, so knowing what you're training against in the Z-score is important. And it can be a tactical decision on picking one sample to compare than another. When you go to amplitude training alone, like what you see on the screen here from John, you don't need to worry about that. You're looking at the quantitative data. You're seeing the frequency that's outside normal limits. You're getting an idea that that's correlated to a certain function you want to target, and then you can manipulate 3 frequency band training like John is showing on screen very quickly. So I kind of tend to like to start with what John's showing here, and I gather my targets, if you will, from the quantitative analysis that correlates with their symptoms.
So we have one more question coming in, and it's a kind of a mixed answer that both I and Dr. Hagedorn can provide. So they're wondering, is the equipment sold to only licensed clinicians, or is it also sold to researchers? So from ThoughtDesk perspective, we exist both in the research and clinician market, so one can purchase our equipment either way. I'm assuming the same thing is true of Evoke, that your QEEG system is also sold both to researchers and clinicians.
That's right. Yeah.
Okay. So yeah,
the reasons for that, we're both medical device companies with a ton of regulations in the United States around having good quality equipment, and there's a lot of rules for medical device manufacturers that we adhere to, and those are the reasons why.
That they're appropriate for both different types of individuals. Yeah. All right. So thank you very much, Dr. Hagedorn. I don't have any other new questions coming in, so I think I'll be bringing this presentation to a close. And for the first time ever, I have managed to keep a presentation exactly within the time limits that we foresaw. So I'm proud of that. So thank you very much, everyone, for your participation. And of course, thank you very much, Dr. Hagedorn, for your delightful discussion of the Evoke QEEG system and how we can take the results from there and we can apply those into the thought technology software, whether it's neurofeedback or heart rate variability. If any of you have any questions a little bit later on, you can always shoot them over to me, John Bale at thoughttechnology.com, and I'll be happy to get back to you. If any of those questions are more appropriate for Dr. Hagedorn, I can totally get a hold of him too, because apparently he gave me his phone number, and that was his mistake. So you'll all be receiving a link where you can review this recording a little bit later. And again, thank you that you joined us, and I'm very happy that you did, and we'll see you all a little bit later, okay? All right, so bye-bye for now, everyone.